Okay, so it's been requested that I do a couple of combustion. I'm going to actually do just a couple of different types of balancing, just to kind of talk through my thinking when I'm doing it. First step is you got to divide the reaction. I don't know how many times I've seen, because there's three reactants or three products, people misplace the line and then their counts go off from side to side. And then I have to have accurate atom counts. So in here I have carbons. I have carbons, hydrogens, and oxygens. I have oxygens in two places, so I can't miscount those. And I have hydrogens in two places, so I don't need to miscount those. And I like to put it in this order, CHO. Whatever order you put it in, make sure the order is the same side to side, because really what you're doing, the whole reason you're balancing, is to have equal numbers of atoms on each side of the reaction. So this number should match this number when I'm done. This number should match this number. This number should match this number. And all I'm going to do is change coefficients, which go in these little blanks right here, right? All right. How many carbons do I have? I have 2. How many hydrogens do I have? I have 6. How many oxygens do I have? I have 2 here and 1 here, so I have 3. On this side, I have 1 carbon. I have 2 hydrogens. And I have 2 plus 1 is 3 oxygens. If you don't know how to count the atoms, then you're going to need to see me for a little bit of remedial work on that. But right now, we're just going to plunge ahead. So I'm going to just start fixing stuff with this one. Now, I could throw a 2 out here, but I'm not sure how that's going to do. Generally, I would throw a 2 in front of any combustion coefficient in front of the hydrocarbon, which is this thing, the CH thing. Generally, I would throw a 2 out in front just as a matter of course, but I'm going to see if I can get this done without doing that. So the first thing I'm going to fix is carbons. And I need 2 over here. I have 1. I need 2. So I know that 2 times 1 equals 2. So I'm going to put a 2 here. That's going to give me 2 carbons. But now my oxygens have changed, right? Because I have 2 times 2. 4 right here plus 1 is 5. So now I've changed my number of oxygens. And then I'm going to go to my number of my hydrogens. I have 6 here. I have 2 here. So I'm going to throw a 3 out here. And 3 times 2 is 6. So I'm going to have 6 hydrogens. But that's also going to change my oxygens. So now I have 2 times 2 is 4 here. Plus 3 here equals 7. Don't lose count, and what I see frequently is I see people wanting to multiply that 3 times this number. 3 times 5 is 15, but that's not true. It's just what I have here, and right here I have 3 oxygens, and right here I have 4 oxygens, but on this side of the equation I have 7 oxygens, 4 plus 3. Okay, now let's see if we can fix the oxygens over here. So I've got 1 oxygen there, so I really need to make 6 oxygens with this remaining spot, because I'm not changing anything here. So I need this to be some multiple of 2 that equals 6. So what can I multiply times 2 and give me 6? 3. That gives me 6 plus 1 is 7. Oh, that was amazingly easy. This is a 1, 3, 2, 3 reaction. And it is most definitely combustion. We know that because O2, CO2, water. Anytime I see O2, CO2, water, and it's not just O2, like here, this has O2 and water, but it doesn't have CO2. And this has O2 and water, but it doesn't have CO2. And this has O2 and CO2 and water, so this is our combustion. All right, let's do another one. Should we do another combustion one? Because that's what the main focus was on for the person that wanted me to make this video. What are we? We're 4 minutes in? All right, let's do another one. So, carbons, hydrogens, oxygens. Carbons, hydrogens, oxygens. And this is an even amount. So I'm not going to mess with this yet. I'm not going to put a 2 out in front of this one either, just because I don't know what's going to happen. Now, normally I would, but let's try this one again without putting a 2 out front. All right, carbons I have 2, hydrogens I have 6, oxygens I have 2, carbons I have 1, hydrogens I have 2, oxygens I have 3. Now I know for a fact that I'm never going to have any multiple of this 2 here to make 3. And I know I already have 2 here, and so whatever I multiply this times, 2 times 2 is 4, 3 times 2 is 6, 4 times 2 is 8. This is always going to come out an even number, and if I add this one, it's always going to be an odd number. So I need this 1 to become an even number, and the easiest way to make an odd number into an even number is to multiply it times 2. So now I have 4 hydrogens, I have 2 oxygens plus these 2 oxygens, so I have 4 oxygens. All right, well, 4 oxygens, 4 hydrogens. That's not even going to fix hydrogens for me, is it? So that's not going to work, is it? Nope. Well, how about, let's do this. Let's try and fix carbons first and see where that takes us. So I'm going to go back to ground 0 and go in the order I should have gone in and go back to here, and let's start. So that gives me 2 carbons, that gives me 4, plus 1 is 5 oxygens. Alright, and then I'm going to fix hydrogen, so I'm actually going to throw a 3 out here. That's going to give me 6, plus, so I've got 2 times 2 is 4 oxygens, 3 times 1 is 3 oxygens, 4 plus 3 is 7. Alright, let's see if I can fix it. All I have is this one place for oxygens, and no multiple of 2 equals 7, so that's not going to work. So what I'm going to do is multiply this times 2, multiply that 3 times 2, and I'm going to try a 6 here. And it's going to change all my numbers. Now I have 12 hydrogens, and now I have 6 oxygens plus 4 oxygens equals 10 oxygens. 2 times 2 is 4. 6 times 1 is 6. Excuse me. So now I have 10 oxygens. Okay, now let's see if we can fix hydrogens. So we're going to put a 2 out here. That's going to make carbons 4. And sometimes you're going to have to go back and forth and back and forth and back and forth. But if you see yourself getting in a loop, then you need to stop, start back at the beginning, try a different tactic. All right, so now I have 4 carbons, and now I have 12 hydrogens. My hydrogens are right, okay? Now, again, I'm going to go back to the top. I'm going to try and fix carbons first. So I'm going to strike through this, and I'm going to make this a 4. That gives me 4 carbons. Oops. That gives me 4 carbons, and then I have 8 plus 6. 8 plus 6. 14 oxygens now. You see where I'm getting at? 6 times 1. I have 6 oxygens here. 4 times 2. I have 8 oxygens here. 8 plus 6 is 14. Okay, my carbons are right, 4 and 4. My hydrogens are right, 12 and 12. My oxygens are wrong, but what times 2 equals 14? 7. We love fixing things that are by themselves. So this oxygen being by itself, it's kind of a boon because we can save it to last and fix it really easily, right? Okay, shall we do one more? Let's do one more on here. And in this case, I want you to notice that if I had thrown a 2 in front of this hydrocarbon, it would have worked out much better from the beginning, right? So I shouldn't distrust myself. I should throw that 2 out there. Okay, what do we have? What do we have? Let's do this double displacement here, this big nasty thing. No, let's do this single displacement because I want to prove a point here. Okay. Okay. Now, what do I have in here? I have magnesiums. I'm going to put my arrow down the center. I have silvers. And then I have this NO3. Now you can list it out as nitrogens and oxygens. It'll work out the exact same way, but I'm going to save you a little work. And I'm going to tell you, if it's in parentheses on this side, and it's exactly the same on this side, then put it in parentheses on this side. And let's just call this NO3 element. This is the element of NO3. It doesn't mean that there are 3 of them. Anything inside this parentheses is protected, right? It never changes. So NO3 groups. And then over here we have magnesiums, we have silvers, and we have NO3 groups. All right, magnesium I have 1, silver I have 1, NO3 groups I have 1. Silver I have 1, magnesium I have 1, and NO3 groups I have 2. That's what that 2 means. It means I have 2 of whatever's in these parentheses. So I have 2 of these NO3 groups, right? I could make that go away and just look like that. I have 2 NO3 groups. But we have 2 of them. Okay, there's only one thing to fix here. There's one place to start. And ding dong. What you can't get wrapped up in is saying, oh, if I change this to a 2, it's going to change these as well. Don't get that far ahead of yourself. Just see the 2. Know that I need to change this 1 into a 2. That means it needs a 2 out front. That means that I'm changing my silvers to 2. I'm also changing my NO3 groups to 2. All right, now I have something to fix from this side to this side. I have 2 here and 1 here. So I'm going to multiply this times 2. Oh, it looks like we're done. Fairly simple, right? That's most of what balancing is. It's just trial and error. It's just changing things to reflect, just changing coefficients to reflect the number of atoms I need on this side when compared to the other side. All right. Since I have the blank paper and this video is already 12 minutes long, oh, did I say already? I meant only. I'm going to go ahead and do this guy. So we have iron. This is Cl. It's not Ci. Capital I's look like that. I'll try and make everybody on test put capital I's. So this is Cl. I have Na. And then I have this OH. But I notice that it's in parentheses on this side. If it's in parentheses on this side, I'm going to make it in parentheses on this side. And so I have OH groups. I have 1 iron. Nope, let's put our dividing line. A's and OH's. Be very careful with your capital letters. These are elements. This is an element. 1 capital letter means 1 element. Okay. 1 iron, 3 chlorines, 1 sodium, 1 OH. 1 iron, 3 OH groups, 1 sodium, 1 chlorine. All right, what are we going to fix? Let's fix chlorines first. Okay, we got 3 over here, 1 over here. So what times 1 gives me 3? 3 times 1. So now I have 3 chlorines and I have 3 sodiums. Okay, now I got to fix sodiums. So what times 1 gives me 3? 3, so I'm going to throw a 3 in front of where my sodiums are, and that changes that to 3, but that also changes OH groups to 3. Oh, happy day. Oh, why did I write OH group? I had it in my head. To 3. Happy day. We're balanced. 1, 1, 3, 3, 3, 3, 3, 3. Done. This is a 1, 3, 1, 3 reaction, and it is a double displacement. Oh, this guy up here, that guy, single replacement. How do I know? I have a single element on this side of the arrow, and it is silver. I have a different single element on this side of the arrow, and it is magnesium. That is a single displacement. Does that make sense? I hope so. I hope this helps the people that watch it. And if you have any questions, you know you can hit up my Remind anytime you want. Before class, after school, whenever. I am here at your disposal.